Hi, today we're going to solve multi-step inequalities, but before we get to that, let's talk a little bit about inequalities. So if you notice, there is a number line up here. So here, of course, is your zero, and then all the negatives are to the left and the positives are to the right. So based on the number line, it may help you decide on number one if 3 is greater than 5. So, of course, 3 is not greater than 5, so we'd say that that is false. Is negative 3 on number 2 less than 5? So a negative is always less than a positive, so this is true. And on number 3, is 4 greater than or equal to 4? Well, it's not greater than, but it is equal to. So this would be a true statement. All right, let's go ahead and take a look at the translations. Number 4, if you have the phrase is at most, it represents less than or equal to symbol. So for example, x is at most 9. So that's how you would write the inequality expression there. X is less than or equal to 9. On number 5 over here, is at least represents greater than or equal to symbol. So the example would be x is at least 10. So this is the way that you would write your inequality symbol. Just a little, I don't know if it would be helpful or not, but I have used the phrase just in general. Sometimes less is more. So like on number 5, you have least, but it's the greater than symbol. So it's kind of opposite of what you would think. So less is more, and then on number 4, more is less. So the most is like more. So more is less is more. So they're kind of opposite of each other in regards to the inequality symbol. All right, let's go ahead and take a look down here on graphing on a number line. If you have greater or less than symbol, it represents an open circle. So on 6 and 7, you have x is less than negative 2. And so it has an open circle and the arrow goes to the left. So as long as the variable is listed on the left, the direction that the inequality is pointing, so right here, the direction that that is pointing is the direction that the arrow will go. Number 7, x is greater than 4. So you start at 4 and you go to the right. And again, it's an open circle. Now on 8 and 9, these have lines underneath the inequality, which means equal to. So your circle will be closed. So on 8, x is less than or equal to negative 2. So you have a closed circle, and it will go to the left. Number 9, x is greater than or equal to 4. So again, a closed circle at 4, and it will go to the right. All right, let's go on down, and we are going to go over translating the sentence, then graphing the following problems. And just remember that the verb is separates the equation into a left side and a right side. So otherwise, the phrase more than and less than by itself without the verb is would represent an expression like x plus 4 or x minus 4. So let's take a look at number 10. X is more than 7. So you're going to have x is more than, so that more than would be greater than 7. And then we're going to do a number line. And we're not real picky on the number line. All we need to do is put the number 7 there. And then what's most important is that you understand, is this going to be an open circle or a closed circle? So this will be an open circle. And greater than will go to the right. So that's really all we're looking for on the number line. Number 11, x is at most 10. Remember, more is less. So this is going to be less than or equal to 10. And again, just your basic number line. Here's your 10. It will be a closed circle unless we'll go to the left. And then number 12, x is at least. So this less is more. So it's going to be x is greater than or equal to 4. And again, this is going to be a closed circle, and greater than will go to the right. All right, now what we're going to do is look for a pattern. So you see the 4 different columns. The first column is your beginning statement. Then it's a transformation. So what we're going to do to both sides, the resulting statement, and if it's true or false. So on problem 1 here, 7 is equal to 7. Well, if we add 3 to both sides, we get 10 is equal to 10. So this is a true statement. Oops. Number 2, 8 is equal to 8 is your beginning statement. If we divide both sides by -2, we get -4 is equal to -4, which is also a true statement. Then we have on number 3, 8 is equal to 8, so that when we multiply both sides by -4, we get -32 is equal to -32, which is also a true statement. Now then, those are all equal statements. Now we're going to get into using the inequality. So on number 4, 5 is less than 7. If we add 3 to both sides, we get 8 is less than 10, which is still a true statement. Number 5, 8 is greater than 7. If we subtract 10 from both sides, -2 is greater than -3 is still a true statement. Number 6, 6 is less than 8. If we divide both sides by -2, so 6 divided by -2 is -3, and 8 divided by -2 is -4. Is -3 less than -4? No. -3 is greater than -4 because -3 is closer to 0. Let's look at number 7. 10 is greater than 5. If we multiply both sides by -4, we get -40 is greater than -20, which is false. -20 is closer to 0, so that's greater. Number 8. -2 is less than 4. If we multiply both sides by 8, is -16 less than 32? That's true. Number 9. 18 is less than or equal to 36. If we divide both sides by -2, we get -9 is less than or equal to -18. That is false because -9 is closer to 0, so it would be greater than. Number 10. -10 is less than -4. If we multiply both sides by 2, we get -20 is less than -8, which is true. Number 11, -6 greater than -8. If we multiply both sides by -1/2, which basically means we're just dividing by -2. So -6 divided by -2 is 3, and -8 divided by -2 is 4. Is 3 greater than 4? False. So I want you to go back and look to see what we were doing with all of the ones that was false. So we had, if we go back and look, number 6, we divided by -2. 7, we multiply by -4. 9, we divided by -2. And 11, we multiply by -1/2. So what happens here is that, therefore, when you multiply or divide by a negative, it doesn't matter whether it's a whole number or a fraction, you must flip the symbol. And I'm going to go ahead and put inequality symbol instead of just symbol. In order to make it true, you're going to need to flip the inequality symbol. So let's see what happens when we work some multi-step inequalities here. So we have the -4 we're just going to bring down. That minus sign in front basically says change all the signs inside. Or if you want to put a -1 right there and then do your hippity hoppity, you can do that. So -1 times 3x is -3x. And -1 times -5 is a +5. So what happened in there is that positive 3x became a negative and that -5 became a positive inside the parentheses. And this is greater than 13. So we're going to work it just like we did if that inequality was an equal sign. And the only thing that may change is right at the end when you multiply or divide by a negative. So we're going to combine the like terms here. -4 plus 5. So remember the little row row your boat song? Same signs add and keep, different signs subtract. So we're going to subtract. So -4 plus 5 or 5 minus 4 is 1. Take the sign of the higher. Then you'll be exact. So the higher number is a positive. So we're going to look at 1 minus 3x is greater than 13. All right, so now we've got a constant here on the left, a variable term, and then over here we have a constant. So we have more constants, so we're going to need to get those on the same side. So let's go ahead and subtract 1 from both sides, and I'll go ahead and draw a line down through the middle, just like it were the equal sign. So this cancels out, so we'll bring down -3x is greater than 13 minus 1 is 12. Now, notice what we're going to do on this last step. We have to divide by a -3. When you divide by a negative, you're going to flip the symbol. So instead of greater than, it's going to become less than. And 12 divided by -3 is -4. Okay? And then it does say graph the answer on a number line. So we'll just come over here, graph it on a number line. So we have our -4, and it's just less than, so it's going to be an open circle, and then it's going to go to the left. All right. And if you did want to check it, like you could choose a number that's less than -4, like -5, and then put it in place of the x right up here, and see if if it makes the left side greater than 13. All right, let's look at number 13. Now we have a fraction. So on this, you're going to have -3/4 times 8. So I'm going to go -3 times 8 is -24. Divided by 4 is -6x. And then -3 times -20 is a +60. Divided by 4 is 15. So this will be +15. So that worked out nicely. Even though it started out kind of ugly with a fraction, it ended up coming out to be whole numbers. So this is less than -15. All right, so here we have just a basic two-step equation. We have a variable term here, we have a constant, and we have a constant. So we want to get our constants on the same side. So let's move this over. So we're going to subtract 15 from both sides. Cancels out. And then we're going to bring down our -6x is less than, same signs, add and keep, you keep the sign. And then we're going to divide by -6. Divide by -6 to both sides. And again, we are dividing by a negative. Now, if we weren't dividing by a negative, we would leave the symbol as it started with, which is less than. But since we're dividing by a negative, we flip the inequality symbol, and -30 divided by -6 is 5. And then we'll have our number line, not picky. Just have our 5 right there. And in this situation, again, it's another open circle. It's greater than. So we're going to move it, make the arrow go to the right.